Okay, we're going to work our way towards solving some quadratic equations, and one of those ways that we solve a quadratic equation is by factoring. Problem with factoring is it doesn't always work. Factoring is pretty handy if you learn some special tricks and you're really good at mental math. It's always I'm pretty good at factoring myself because I know my times tables and I can add in my head real well. So those are good attributes in becoming a good factorer. Today we're going to work on common and binomial factors. A binomial factor is, when I say binomial, that means two terms. So when I turn quadratic into binomial factors, what you'll normally have is two sets of two terms. You'll have one binomial in a set of parentheses, and then a second binomial in another set. Otherwise, we'll also find common factors, and what that is there anything that goes into every term that's given to you. Finally, we'll finish off with some special quadratic factors. That's going to be a difference of squares, and then a perfect square trinomial factors into a binomial squared. So leading up till today, I had you guys do binomial squares in your head. You know, first one squared, twice the product, last one squared. We're going to go backwards then. So starting off pretty easy here. We're going to find two numbers whose product is C and whose sum is B. We do that when the A term is 1. So this is if you've just got x squared plus bx plus c. A is just 1. That's when you're going to do this. If C is greater than 0, the two numbers have the same sign as B. If C is less than 0, the two numbers have the opposite sign. So here, C is 9. It's positive. That tells me that the factors that I come up with are going to have the same sign. Now, my factors are going to look like this, and the first terms are going to be x and x, because x times x is x squared. And that's what I want to get when I FOIL this back up. Okay? So I said C was positive, B is also positive, so that tells me that they're both going to be positive. C tells me that they're the same, B tells me they're both positive. And all I'm doing here is coming up with something that multiplies to be 9 and adds up to be 10. So that should tell you right here that my two numbers need to both be positive, because if I had a negative and a positive, there's no way I'm going to get that positive 10 at the end here. And also, I'm not going to multiply to be 9. If I did negative 1 times 9, that'd be negative 9. So I can't have a negative and a positive. I need to have either a positive and a positive, or a negative and a negative. Well, it can't be negative and negative because it's got to add up to be a positive. So, again, C is positive, B is positive, they're both positive. 1 and 9 are the things that work. 1 times 9 is 9, 1 plus 9 is 10. 1 and 9. It doesn't matter if you'd have put the 9 first and did x plus 9 times the quantity x plus 1, that's the same thing. Next one. Here I've got C is positive 40 and B is negative 13. So that tells me, C tells me same sign. Would be x and x here again. But in this case, since B is negative, they both have to be negative. Hopefully that makes sense. In order to get a positive, when I multiply, I have to have the signs the same. So like I could have negative 1 and negative 40. But it needs to add up to negative 13. So negative 1, negative 40 is 40, but it doesn't add up to negative 13. So here's all the things that work. I don't know why I put a 200 there. That should have been, I got a little carried away there. It should be negative 2 times negative 20. That adds up to negative 22. Negative 4 times negative 10 is 40, but that adds up to negative 14. The last one is negative 5, negative 8, and those are the ones we want. So it's x minus 5, x minus 8. All right, finally here I've got one where C is negative. When C is negative, then I'm going to have one of each sign. So I got to multiply to be negative 12. So I could have something like negative 1 and 12, but I could also have 1 and negative 12. Well, I need positive 4 when I add. These are either going to be 11 or negative 11 right here, so those don't work. Let's try 2. negative 2 and 6. That adds up to 4. That's what we want. So I'm going to have x minus 2, x plus 6, and again, it could be x plus 6, x minus 2 in that order. That would be fine. One of the worksheets that I give you has got something that looks a little trickier. It's got not just one letter, it's got two. So it might have x squared plus 4xy minus 12y squared. So this would be the same exact thing, except for I've got a y and a y squared brought into it. Those aren't any different. All you need to do is factor the same way, except for instead of x minus 2, you'll have x minus 2y. Instead of x plus 6, you'll have x plus 6y. That way, if I FOIL it back out, I get x squared, I get 6xy, and then I get negative 2xy. Those go together to make 4xy. And finally, I'd have negative 12y squared. So if you've got that extra letter, don't fret, still do the same work. Just put that extra letter at the end of each binomial. Okay, so that's what you do if you've got 1x squared. What do you do if you've got something other than 1? I've got a list of things to go through here. The first of which is to divide out any numbers that go into all terms. So when you're factoring, always look to see if there's anything that goes into all terms. And divide out a negative 1 if the x squared term is negative. I don't want x squared to be negative. So if I've got negative 2x squared plus 3x minus 5, I don't even know if that factors, you're going to change that to negative 1 times 2x squared minus 3x plus 5. I want my x squareds to be positive. And when I factor, I want my x's to be positive. For some reason, some people like to put negative x, negative x. Notice up here, I didn't have negative x, negative x. I had positive, positive, positive x, positive x, positive x, positive x. Don't ever put negative x, negative x. Okay? So after you take out the common term, you're going to write down, excuse me, all the products that are equal to a in front of the x squared. And we'll call those m and n. And then everything that's equal to, or our number that's equal to c, we're going to write down everything that equals c. So like if c was 10, you do 1 times 10, 2 times 5. You got to be careful. I've got some notes here. If b is positive, c is positive, then both p and q are positive. And p and q, I'm saying, are the factors of c. So like again, if c was 10, p and q could be 1 and 10. Or p and q could be 2 and 5. If b is negative and c is positive, then you got both negative. Same thing I talked about up above. And then if c is negative, you need 1 of each. Now, one of the lists that you write down, you're going to want to reverse. Makes it look a lot longer, but it might be necessary because you might not find the answer if you don't reverse the list. So what I mean by that is, if I've been saying 10. If I had 1 and 10, 2 and 5, I might need to write 5, 2, 10, 1. I got to do that for one of my lists. Pick whichever one's got the least amount of factors. Finally, we're going to find mq times np. I'll show you how that works. And that's your b. And then we plug them into mx plus p and x plus q. So let's look at a problem like that. So I've got 12x to the third plus 21x squared plus 9x. First step is to take out what they have in common. Well, what goes into 12, 21, and 9? I can take a 3 out. Not only can I take a 3 out, but they all have an x in them, so I can take an x out. So I've got 12x to the third divided by 3x. That's 4x squared. 21x squared divided by 3x is 7x. And 9x divided by 3x is 3. Okay? When you get done, don't forget to include the 3x in your answer. That is one of the factors. This one's going to have a monomial in front. That's what 3x is called, a monomial. This is one term. And then you'll have 2 binomials after that. Now, how do you get the binomials? We're going to write down A, and we're going to write down C. And I'm going to write the factors of A. They're 1, 4, 2, 2. I'm going to write the factors of c, but I have to be careful. I have to decide what the signs are. And since c is positive and b is positive, my signs are both positive. So it's 1 and 3. I also said that you're going to need to reverse one of these. So I would reverse this one right here because it's less to do. I only have to reverse one pair of numbers. Well, actually, it would have been the same because 2, 2 reversed is still 2, 2. So this would have been, I would only have to write one more pair anyways. Now, I said that this was mn. So on the left was mn. And this was PQ. That's a G. That's not good. PQ. There we go. Okay, so I want you to do MQ plus NP. Now I just do this in my head. So what I'm doing is I'm taking M times Q, which is 3, and then 4 times 1, which is 4, and I add those up. Now, what do I get when I add those up? I get 7, and that's what I want. I want to get 7. I want to find the MQ plus NP that equals B. So I got 3 plus 4 is 7, and that's what I want. So these are the numbers I'm going to use right here. I'm going to circle those, and then I'm going to plug them in like this. I'm going to say that 1 and 4 are my x's. So it's going to be 1x and 4x. Just put them in order. And I told you to, I gave you a pattern in case you like that. I did mx and then I did nx. That's the factoring that I showed you down here on the previous page. mx, nx. And then it's mx plus p and nx plus q. So it was mx plus p. Well, what's p? P is the first number. So what happens is the first number here goes with the first number here. So it's x plus 1. And then what's q? That's the second number. So my second number, 4, goes with my second number, 3. So it's 4x plus 3. And I would certainly encourage you to check to make sure mentally that that works out. FOIL this out. Is x times 4x is 4x squared. There's my 3x plus 4x gives me 7x in the middle. And then 1 times 3 is 3. So that works out. So my final answer has got the 3x in front of it, and then an x plus 1, and a 4x plus 3. That's totally fair. Let's do that again. Take out what they have in common. What does this one have in common? Well, all the numbers are even, so I'm going to take out a 2, but you notice there's a negative in front, so I need to take out a negative 2. So if I divide everything by negative 2, it'll be 2x squared minus 7x plus 6. So my final answer is going to have a negative 2 in front. I can't forget that. I'm going to write that down there now. Now I write A as 2 and C is 6. And I'll write the factors of 2. Well, that's 1 and 2. And I got to flip one of these, so I might as well flip this one. It's pretty easy to do. Make that 2, 1. Now when I write the factors of C, I have to think about the signs. C is positive and B is negative. That tells me that these are both negative over here. So I can do something like negative 1, negative 6, or negative 2, negative 3. Now I'm trying to find the outside plus inside that gets me negative 7. I'm trying to come up with negative 7. So let's try it out. We got negative 6 and negative 2. Well, those add up to negative 8. That didn't work. So I got to try something else. Now I would not skip down to the 2, 1. I would try 1, 2 with this one. So it's 1 times negative 3, negative 3. 2 times negative 2, negative 4. And when I add those together, I get negative 7, and that's what I want. So I found the numbers that work. They're right here. Now I just need to be able to plug them in. The 1 and 2 are my x's, and they go in order. 1x, 2x. The negative 2 and negative 3 over here are my numbers, and they go in order. Negative 2, negative 3. Mentally FOIL that out. Make sure the middle actually gets you negative 7. There's negative 3. There's negative 4. Gets me negative 7. Therefore, I've got this factored correctly. Done. Example 6. Anything go into all three? That's the first thing I checked, and I say no, nothing goes into all three. So I'm stuck using 12 and negative 20. Well, this one has a lot of factors. 12 is 1 and 12, 2 and 6, 3 and 4. Negative 20, because it's negative, tells me that I've got to have one of each sign. So I could go negative 1 and 20, but I could also go 1 and negative 20. I could go negative 2 and 10, but I could also go 2 and negative 10. I could go negative 4 and 5, but I could also go 4 and negative 5. I still have to switch one of these. I won't want to switch the right because that is a lot of factors. So I'll switch the one on the left, so I can have 4, 3, 6, 2, 12, 1. And this is where it pays off to be good at multiplying in your head and adding in your head. I want to come up with negative 1 when I do outsides and insides. 20 minus 12. 1 times 20 is 20. Negative 1 times 12 is minus 12. That's 8. That's not 1. If I go on to the next one, I'm going to have negative 20 plus 12. That just turns it into a negative 8. So keep that in mind. When I switch the signs on the right like that, I'm just going to get the opposite answer. That saves you a little bit of time if you realize that. Okay, now I know a trick. Rather than keep going down here, I got 10 minus 24. That's negative 14. Therefore, when I use this one with it, I'm going to get positive 14. Next one, it'll be 5 minus 48. That's negative 43. Next will be positive 43. Yikes. That was only with 112. Now I'd have to go 2, 6. So I said I know a trick. The trick is, when this number in the middle is really small, we've got a negative at the end, look at the numbers that are really close together. Usually it'll be the numbers that are close together, like 3, 4, and 4, 5. So let's focus our energies there. 3 times 5 is 15. Excuse me. 4 times negative 4 is negative 16. Oh, look at that. So me knowing that, I would have got to the answer right away. I wouldn't even mess around with the 112. I would have went straight to the 3, 4 and see if I could get that to work with that 4, 5. And it worked out. So here are my numbers. 3 and 4 are my x's, so it's 3x and 4x. That way I get 12x squared when I multiply them. 3x and 4x. And then negative 4 and 5 are my numbers. I just put them in order. Minus 4 plus 5. That way I get negative 20 at the end. But I also get 15x minus 16x is negative 1x. So 3x minus 4 and 4x plus 5 are my factors. At this point, because the video is getting a little bit lengthy, I'm going to call it quits and then do the special factoring on the next page on a separate video. So if you need to look at that, please do so. Otherwise, thanks for watching. Have a great day.